Hello, this is Math 1428, remote delivery for May 8th, and this is dealing with section 8.7 in your book. The topic page wants you to learn is to expand the power of a binomial using what's called Pascal's triangle. And a second objective is to find a specific term of a binomial expansion. Let's talk about this. Okay, notice that there is a pattern. When we take a plus b to the 0, if a and b aren't both 0, then that is 1, and so we have a 1. If we do a plus b to the 1, we get this. If we do a plus b whole squared, you see there is a middle term, and because we take a plus b times a plus b and multiply it out. When we take a plus b cubed, again, we get more terms because we're taking a plus b whole squared times a plus b yet again. So you see you get a complicated pattern that looks like this. Notice it's in the shape of a triangle. And so what you see is you're looking for patterns, and there are patterns in the numbers and the figure like a triangle. So the idea is you are supposed to be able to do this calculation for any number, and you're supposed to tell also, if we ask you, what is a specific term in the expansion. This does involve Pascal's triangle, and here's a picture of Pascal's triangle. So the numbers you get by creating this triangle. And so this is the 0 row, this is the first row, this is the second row, and so on and so forth. And those numbers can be found along this diagonal. And the way you compute this is you get 1, 1, 1. But now, to get this number, you say, what is the sum of the two above? So that is a 2. To get this number, you say, what is the sum of those two numbers? It's a 3. The sum of these two numbers, it is a 3. And the ones are always on the main diagonal. Here you get 4, 6, 4, and then 1. Here you get 5, 10, 10, 5, and 1. Here you get 6, 15, 20, 15, 6, and 1. So you could build this Pascal triangle to any height. Okay, so to do the expansion then, the expansion is a polynomial, and there is one more term than the power of n. That is, there are n plus 1 terms in a plus b whole to the n power. In each term, the sum of the exponents is n. The exponents start with n, the power of the binomial, and decrease to 0. The last term has no factors of the first term, and the first term has no factors of b. So powers of b start with 0 and increase to n. And the coefficients start at 1 and increase about halfway, and then they decrease down. Just use Pascal's triangle and you will be. So here again is Pascal's triangle, but now you see the numbers are 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, and 1, and so on and so forth. And notice that we start with the power of a to be 5, and we decrease it by 1 each time. We start the power of b to be 0, and we increase it 1 each time. And so this theorem just really says that, and we talk about these being the numbers that we get from the n plus first row of Pascal's triangle. So here's an example. We expand u minus v to the 5th power. Now notice that this is u plus minus b, so we do get a minus factor there. And so this is u plus minus b. Now we use the 6th row, so the coefficients are going to be 1, 5, 10, 10, 5, and 1. 1, 5, 10, 10, 5, and 1. But now we're going to have u to the 5th. Here you have u to the 4th, but now it's minus v to the 1st. Here you have u, that's supposed to be cubed, and this is minus v squared. This is then u squared minus v cubed, and this is u to the 1st, and that is minus v to the 4th, and then this is 1 times minus v to the 5th. Now we do have to be mindful of a sign, so your final answer is going to be this one. The second objective talks about finding the k plus first term. Well, the k plus first term is going to be ck. You get that from the row in the Pascal's triangle, and then you have a to the n minus k, and then you have b to the k. An example of this. So we're going to find the fifth term in this expansion. So the first term is 2x. The next term is minus 5y, so it's 2x plus minus 5y, and I'm raising that to the sixth power. So I go to the appropriate row, the seventh row of Pascal's triangle, and I can work through and get this, and this is the answer that you should get. Now more than ever, time is precious. Each day must count. Do the math. It will make you strong. Take care of yourself and of each other. God bless.